equation here is given to us in factored form. So we need to have factored form with those parentheses in order for us to figure out our x-intercept. All right, so going through the steps here, we're going to begin, I always like to begin with end behavior. That was kind of the first big thing that we learned, that we talked about. And because this is in factored form, I can see that I need to add the exponents to get my degree. So here I can see that my degree is odd. And I don't see anything out of the very front, so for my leading coefficient, I'm assuming that it's a positive 1. And so that's going to be in the category of end behavior down, up. Now for my zero. Zeros are the x-intercepts. I'm just going to look at these one piece at a time. So the first piece here, I'm going to be looking at the x minus 2 parenthesis part. Well, to get my x-intercept, I need to turn it into the opposite sign. And I actually have a little bit of information here over on the side board. The reason that's happening is because we're really setting the equation equal to 0, set each factor equal to 0, and solve for x. And so if you think about doing x minus 2 equals 0, we have to add 2 to both sides. That's going to turn into a positive 2. Marcus? Oh, thank you. Yes. I thought that was a 3 in the middle. It is not a 3. It is a 2. I was thinking 3 plus 3 plus 1. Yes, it's an even degree of 6, and so end behavior is going to be up, up. Thank you. Okay, so we've got our first x-intercept here of 2. Now, when it's asking for multiplicity, that is just the exponent attached to that part. In this case, the exponent attached to that first parenthesis is 1. And because it's a 1, we know that it's going to cross through. All right, so let's move on to the second piece here. So because our second parenthesis is x plus 3, we're going to turn it into negative 3. The exponent attached, the multiplicity is 2. And because it's an even multiplicity, because it's 2, we know that it's going to bounce on that x-intercept. All right, and then finally for the last one here, for the x minus 1 part, we're going to turn that into a positive 1. That is a multiplicity of 3, and if it's an odd multiplicity greater than 1, it's going to wiggle. All right, now the final thing we'll do here in the setup before we sketch our graph is calculate our y-intercept. We're going to do that by plugging in 0 for x back into the original equation. Then we're going to think about order of operations to start to simplify this down. So we're going to simplify each little parenthesis part first. So it's going to turn into this. And then order of operations says that we need to deal with the exponents first before we multiply. So I'm just going to keep that negative 2 there in the front. We're going to do 3 squared, which is 9. Negative 1 to the third is really negative 1 multiplied by itself 3 times. It's an odd number of negative signs, so the result is going to stay negative. All right, at the very end here, in total, we've got an even number of negative signs, so it's going to turn our final answer into a positive number, and we're really just thinking about doing 2 times 9, so our y-intercept is going to be positive 18. All right, when it comes time to sketching the graph, I always start by labeling and plotting my x-intercepts. So it's going to cross through an x-intercept of 2. It's going to bounce at the x-intercept of negative 3. And then we see over here that it's going to wiggle through the x-intercept of positive 1. We don't need to make 18 little lines for the y-intercept, but let's go ahead and plot a point up here somewhere where it's positive. And we're going to label it as 18. And then finally, the end behavior of up, up, that is how we get this curve started so that we can actually start to go through the inside part. So for the bounce at the beginning, we're just going to make sure that it touches, and then it's going to turn around. It's going to come up here so that it can pass through that y-intercept. It's turning around so that it can wiggle through the next one. Now remember, for the wiggles, I try to make my pen go a little before the x-intercept. Make it a little flat on top of it and then have it go down a little bit after. And then notice that we need to have another sharp turnaround point so that it can cross through this final x-intercept. And for the cross-through part, we just want to make that section kind of straight as we can as it's going through the last x-intercept. So let's start by filling in what the factor theorem says. So it says that the expression x minus a is a factor of the polynomial if whatever the a number is a 0. Notice how it's the opposite sign. So if a is the 0, if a is the x-intercept, it's going to turn into x minus a when it goes into the parentheses. All right, so we're going to write a polynomial function that has the zeros of -2, +2, and +3. Now, ultimately, we want our answer to be in standard form. I'm going to show you how to do that. Initially, we're going to start by writing it in factored form. That has all the parentheses. So we're going to start with y equals. And for the first 0 of -2, I'm going to think about doing x minus -2, but that really turns it into +2. So right there, you see that it's the opposite sign. Then we're going to do our next parenthesis, x minus 2, and our last one is x minus 3. Now, that is factored form. To get this into standard form, we are going to go through all of the steps of multiplying this out. Now, we're just going to do this in pieces. So I would recommend doing FOIL for your first 2 parentheses. And so in this case here, if we do FOIL, we get x squared minus 2x plus 2x minus 4. And in this case, actually, the minus 2x plus 2x part is going to cancel. And so we're just left with x squared minus 4. And we're going to bring down this piece here, the x minus 3. And that's going to allow us to just FOIL again. Anytime you have a binomial times a binomial, FOIL is the process that we can use to multiply. So if we go through that process one more time, x squared times x is going to turn into x to the third. So if you think about this, x squared is really x times x. If you multiply it by another x, now there's 3 of them. When we do the outside terms, it's going to be negative 3x squared. When we do the inside terms together, we're going to do minus 4x. And the last term times the last term, negative 4 times negative 3, is positive 12. I'm going to put another little y equals in front. There are no like terms that we can combine because we don't have anything where the variable part is exactly the same. Even though a lot of them involve an x, the exponents are all different. And so this is our final polynomial answer that's in standard form. Now, I want to show you a little something off to the side here. That is the process of doing a trinomial multiplied by a binomial. So we kind of got lucky in this first case, the x plus 2 times x minus 2 ended us up with a binomial, but if we would have had like x plus 2 multiplied by like x plus 5, it would have ended up being a trinomial here, and then we still have to deal with that trinomial multiplied by the binomial at the end. And so it's not FOIL that we're doing, but we can think about a similar type of process. I actually kind of like to think about the distributive property here. Each little part in the first one is going to distribute to every part in the second one. So for example, this would be a times d plus a times e. And then I would do the same thing here. I would take, all right, I'm going to take the next one, and I'm going to distribute that to both parts. So it would be b times d plus b times e. And then I would do that for the third little part here, which is c. C is going to multiply by each of those, distribute to each one. So it would be C times D plus C times E. So we actually get 6 little results there. Now, when you're actually doing this, you may find that some of them are like terms that you can combine together, but that's how you would approach that situation of doing a trinomial multiplied by a binomial. All right, we're going to finish with just one last example. Notice how this one here at the bottom has 4 zeros, but one of them is repeated. So 0 is listed twice, so it says 0, 0, and then we have 1, and then we have -2. So initially, I want to show you how I like to think about this as a start. If I'm told that one of my zeros is 0, to help me keep with this pattern and thinking about the factor theorem, I'm just going to write it as x minus 0 in my first parenthesis. We can certainly go and simplify that down in the next step. I'm going to go ahead and show it twice, since it was listed twice. And then we've got x minus 1. And then at the very end here, we've got x plus 2. All right, now for the x minus 0 part, x minus 0 is really x. So it's the same thing as x times x in the front, and we can shorten that even further by writing it as x squared. All right, now to finish multiplying out a situation like this, what might be easiest to do first is to go ahead and distribute the x squared into the first parenthesis. It's not going to go to both. It's just going to be multiplied into the first part. And right here, when we do x squared times x, that is x to the third. X squared times -1 is minus x squared. Now that little result there, let's hold that in another set of parentheses because the final step is to multiply it by the x plus 2 at the end. Now we are back to having a binomial times a binomial. And so we can multiply this out with FOIL. Notice how the process of FOIL, it kind of is the same as that distributive property process I was showing up there with all the colors. So the first term times the first term would be this arrow. X to the third multiplied by another x. I'm going to turn it into x to the fourth. The outside terms would be like the x to the third is distributing to the second part. So that's going to make it plus 2x to the third. The inside terms is now continuing with that negative x squared. So that's going to multiply by the x. X squared times x makes it x to the third. We're going to make it negative. And then the last term times the last term is going to follow this last arrow here. That's going to make it negative 2x squared. Now, for putting like terms together, we want the variable part to be exactly the same. So notice how we have 2 terms that are x to the third. We can actually put those together by adding the numbers in front. This is really a -1 there. 2 minus 1 is 1. So it's just going to turn into 1x to the third. And then we're just going to bring the other pieces down. You can make that 1x to the third. You can make the 1 invisible. If you'd like, I forgot to put y equals at the front, but I'm just going to write it in there at the end. That would be our final answer in standard form, showing it all the way multiplied.